Hey guys, welcome back. This week is going to be all about a different type of factoring called factoring difference of squares. And before I really tell you what that is, I want to kind of warm us up into it by multiplying out these binomials. And remember how we multiply binomials is you take the first one and you multiply it to both in the second parentheses, and then you take the second number, including that sign, and also multiply that to both things in the second parentheses. So let's write that out. Let's do the blue one first. X times x would be x squared. X times negative 4 is negative 4x. And then the green one. 4 times x is 4x. And 4 times negative 4 is negative 16. And then we'll combine together our like terms. I have negative 4x and 4x. Well, if you actually add those together, you get 0. Those cancel each other out. So what I'm left with, I could just erase that since they cancel each other out. Really what I'm left with is just this, x squared minus 16. And I'll move that minus 16 over. Okay, so before I actually say the pattern, let's do another one. Let's do this one here on the right. And maybe notice like a quick pattern before we start. Look in the parentheses that I had you guys start with. See how they're the exact same thing except for these signs are switched? And then same thing here. Both of these parentheses are the exact same thing except for these signs are switched. So my guess is that maybe those middle terms will cancel out just like it did in this one with the 4x and negative 4x canceled out. So let's see what happens here. Take the 5m, multiply it to both, and what do we get? 5m times 5m is 25m squared. And 5m times negative 3 is negative 15m. And now let's do the next one. The positive 3, let's multiply that to both. Positive 3 times 5m would be positive 15m. And then 3 times negative 3 is negative 9. And again, negative 15m and positive 15m cancel each other out. So I can really just get rid of those. And what I have left is this, 25m squared minus 9. So I'll just scoot that minus 9 over to make everything look a little bit neater, and I'm done. Okay, so the big takeaway, the big thing that we need to get from this slide is if we have the exact same binomial like we did in both of these examples, I'll erase it a little bit just to clear it so we can be reminded what those original problems were. So notice they were the exact same thing except for these signs were switched. If that happens, the middle term cancels out. So that's what this part is saying. What happened each time? The middle thing canceled and we were just left with the one with like the square on it and then just a regular number is what we were left with. And that happened because of these opposite signs. So the positive one and the negative one just ended up canceling the middle terms. Okay. So what these problems are going to look like is I'm going to start by giving you something like this and ask you to go backwards and give me something like that. That's what factoring is. So let's see if we can find what that shortcut is even right now before I move on to the next slide. So remember this final answer was x squared minus 16. So let's pretend you didn't see this. How could I go from this and work my way backwards to what those binomials were? Well, notice a pattern that if we were to just take the square root of x squared, you get x, and if we take the square root of 16, you get 4. And that's exactly the numbers and letters used in both of the parentheses. Okay, so let's try it over here on this one. When we had multiplied everything out, we had 25m squared minus 9. Let's take the square root of both of them. This would be 5m, and this one would be 3. And that's exactly the letters and numbers used in both of these parentheses, one with a positive and one with a negative. And that's the pattern for difference of squares. Okay, so let's try that exact same thing. So here's my expression that I need to have factored, and let's go through the steps for factoring. So remember the first thing you always want to do no matter what is look to see if there's a GCF. Can you take anything out? Because if you can, you want to do that and that'll make your life easier. When I look at this, there's not a GCF. There's no letters or numbers they have in common that I can divide them both by. Okay, so then I'm going to do the square root thing. Take the square root of both of them. Square root of x squared, the square and the square root cancel, so you just get x, and the square root of 25 is 5. So then I just take this and fill it in. it's going to be x and 5, x and 5. One of them will be positive and one of them will be negative. And that'll give me my answer. If I were to multiply this all out, FOIL it out, just like we did on the previous slide, you would end up getting exactly this, x squared minus 25. And that's it. That's the whole thing that we're going to be learning. So some of the examples get a little bit more involved, and so I want to make sure that you guys see that and practice that with me, but that's pretty much the gist of it. I want to also show you another way of thinking about it. Another way of writing it out, and a lot of my students in Algebra 2 really like thinking about this way, and so I think this might be a good way for a lot of you, is if you have x squared minus 25, that's the same thing as this, x squared plus 0x, right? It's totally fine if you add in a 0, minus 25. So what I have in blue and what is originally typed right here are these are the exact same thing. So then if you think about factoring in the normal way, where you write out factors of 25, actually it's negative 25, that add to get you 0. Well, that would be 5 and negative 5. And then you know that those are the numbers you use. So some people like to fill it in with a 0x and then think about what numbers of that third term, that 25, will that you can use to get to 0. So that's another way of thinking about it. Okay, so let's just do a bunch of examples together. And I'm going to show you both ways. So n squared minus 64. If you want, you could fill that in with plus 0n in the middle, and then write out your factors of 64 that will add to get me to 0. So if you're thinking ahead, 8 times 8 is 64. And, well, it's actually negative 64, so I'll make one of them negative. And if you add negative 8 and 8, you also get 0. So I know I'm going to use 8 and negative 8. So I'll fill it in, n plus 8 and n minus 8. And that's it. You're done. So these are very quick problems. Okay, let's do the next one. I'll do this one doing the square root. So let me write my final answer over here just because I had cleared my screen. So taking the square root of both of these, square root of c squared, a square and a square root cancel, so that's just c. And the square root of, actually let me write it above, and the square root of 100 is 10. So my letter is going to be c and the number is going to be 10. We make one of them a minus and one of them a plus. And if you were to FOIL this out, you would get the exact same thing that we started with. And that's it. All right, let's do the last one on the top row. Take the square root of 81, you get 9. Take the square root of x squared, and you get x. So some of you might write this like 9 plus x and then 9 minus x. And that's correct. It's just more normal to write it with the number first. So I'm going to write the x first. Even though it wasn't written first in the original problem, that is the best way to write it. So x minus 9 and x plus 9. Now, before we move on to other examples, I want to show you something really important. Notice that this whole lesson is called difference of squares. That means there has to be a subtraction sign. So all these examples we've been doing, they all have a subtraction sign in between. If you have something like this with a plus sign, you cannot use difference of squares. This pattern does not work for the plus sign. All right, so let's do the fourth one. Take the square root of this whole thing. So you need to think about both the number 4 and t squared. Square root of 4 is 2. Square root of t squared is t. And then take the square root of 1 and you get 1. So these are the letters and numbers I'm going to use. And then do your parentheses. 2t plus 1 and 2t minus 1. And you're done. We already talked about this next one, that you cannot do this because you have a plus sign, not a minus sign in between. So this would not be difference of squares. This would be like sum of squares, you could say, since it's a plus sign. And there's no rule for that. There's no pattern. You can't factor that. Okay, let's do the last one. If I were to take the square root of both of them, then square root of 16 gives me 4, and the square root of a squared gives me a. Square root of 49 gives me 7, and square root of b squared gives me b. So these are the letters and numbers I'm going to use. So one of them is going to say 4a plus 7b, and the other one's going to say 4a minus 7b. And we're done. Okay, pause the screen here if you need to look over things. I'm going to clear it off and say one more thing before we move on. All right, so one more important thing to note is when can you use difference of squares? Because if I had showed you something like this, you can't use difference of squares on that. And so a good thing to know would be, when can I use this rule and when can't I? And the reason why it's called difference of squares is because both of the numbers in the problem have to be something squared. So this is n squared, and this was 8 squared. So both of the numbers and letters was something squared. If I had given you like an x cubed, that is not something squared. That's not x squared. So then I can't do it. Or, let me give you another example. What if I did say x squared, but then I said minus like 70? Well, this is x squared, so that's something squared. But this, if you take the square root of 70, you will not get a whole number. You'll get like a decimal, which means that this difference of squares quick application, quick rule, cannot be applied. In fact, what you'd have to do to solve something like that, x squared minus 70, is you would do this. You would fill it in with a 0x, just like I showed before. So we'd say plus 0x minus 70. And then I would have to think of factors of 70 that add to get me to 0. So I'd start listing them. 70 is 7 times 10, 14 times 5, and I think that might be it. And that is the, none of these numbers, 7 and 10 or 14 and 5, will ever add to get you to 0. So you could try factoring it, but then you would see that it fails. Okay, so this last slide's an important one to go through, because if you notice, these exponents, they are even numbers, which is good because that'll make it work. But they're not x squares. So there is a little bit more to say here. Okay, so let's just keep trying it. I'm going to take the square root of 81 n to the 4th power. Well, the square root of 81 is 9. What is the square root of n to the 4th power? So several weeks back, we saw that a square root, this part right here, a square root is the exact same thing as something to the 1/2 power. So instead of doing a square root, I could just say all that to the 1/2 power. And then it's just exponent rules. 1/2 times 4, 1/2 times 4 is 2. So this is n squared. So the shortcut version of that is that if you're taking the square root of something with an even exponent, then you could just divide it in 2. And that will give you the proper exponent. Okay, so coming back to the problem, square root of 81 is 9. Square root of n to the 4th will be n squared. And then what's the square root of 25 is 5. So now I'm going to use this and fill in my parentheses. So 9n squared 5, 9n squared 5. One of them I'm going to add, and one of them I'm going to subtract. And that's my final answer. All right, let's do the next one. Actually, I'm going to have you guys pause it. Do this one on your own, and then I'll do this one with you. So I think it's really important that you get that time to think and process on your own while you still need to check your answers. So go ahead and do that. Pause the screen here, do the second one, and then I'll go over the third one with you. Okay, so hopefully you took the square root of both. The square root of n to the 6th, again, another way of thinking, or not n, x to the 6th, another way of thinking about it is instead of square root, you can think 1/2 power, and then you multiply 6 times 1/2 and you get 3. The other way of thinking about it is just divide the exponent in half. So the square root of n to the 6th, or x to the 6th, goodness, is x to the 3rd power. And then the square root of 16, we know that that's 4. So I'm going to use x cubed and 4 and write my 2 parentheses. And I'll put a plus in one and a minus in the other, and then I'm done. All right, I'm going to clear the screen here, so pause if you need to look it over. And let's do the last one together. So take the square root of both. Square root of 64 is 8. Square root of m to the 4th would be m squared. Square root of 9 is 3, and the square root of n squared is n. So I took the square root of everything, and then those are the two terms that are going to be in my parentheses. So 8m squared and a 3n, and one of them you put a plus sign and the other you put a minus sign. And again, what this means, just to recap, since this is our last example, is if you were to FOIL all this out, you would end up getting exactly what we started off with. And so when we go backwards, like what we just did, that is called factoring. Okay, so now you guys know how to factor by difference of squares. This is a very, very, very common pattern that you'll see, again, a little tiny bit in geometry and a lot in algebra too. So it's a very common pattern, a good one to be able to get good at. That way the next time you see it, it's easy. And that's it for today, you guys. Have a good one.